job. And what might you look forward to a little bit farther down the line for the Institute as humans return to our satellite moon?
I haven't thought too much about the humans because I see so much interesting happening in the next decade before humans will get there.
Well, you've got Lunar Reconnaissance Orbiter just about to make the trip.
That's right, and LCROSS, the mission that will piggyback with it and will shepherd the upper stage into a crash landing into one of the permanently shadowed craters near the lunar pole that might contain water. And then there are all these international missions. The Chinese and Japanese and Europeans have had lunar missions since the U.S. did. India will be launching this next year. There's a lot of interest out there, first in lunar orbiters, and then later in this decade, a number of lunar landers, which will be linked together to form what we are calling an international lunar network, too.
It certainly seems that whether it's ever declared officially by a lot of agencies, that what the Planetary Society has been calling the International Lunar Decade is really upon us.
That's right. You folks have been out in front on this, and I think we all appreciate it.
David, I want to thank you very much for joining us and wish you the best of luck, especially as you wade through all of those proposals in just a few weeks' time, and we'll look forward to hearing about the lucky winners, if I can call them that.
Thanks, and keep looking up. The moon is up there, and it's looking down on us, and we're going to be going there.
I wouldn't miss it. David Morrison is the interim director of the NASA Lunar Science Institute. As you heard, he founded the NASA Astrobiology Institute, upon which the Lunar Institute structure is based. He remains a senior scientist at the Astrobiology Institute, which we have spoken of in the past on this program. He has a very distinguished career elsewhere in planetary and space science and is the author of many books. I'll be back in a minute with Jack Gregg, the executive director of SUSUI, sponsor of the Lunar Regolith Challenge. This is Planetary Radio.
Hey, Bill Nye, the science guy here. I hope you're enjoying Planetary Radio. We put a lot of work into this show and all our other great Planetary Society projects. I've been a member since the disco era. Now I'm the Society's vice president. And you may well ask, why do we go to all this trouble? Simple. We believe in the PB&J, the passion, beauty, and joy of space exploration. You probably do too, or you wouldn't be listening. Of course, you can do more than just listen. You can become part of the action, helping us fly solar sails, discover new planets, and search for extraterrestrial intelligence and life elsewhere in the universe. Here's how to find out more.
You can learn more about the Planetary Society at our website, planetary.org/radio, or by calling 1-800-9-WORLDS. Planetary Radio listeners who aren't yet members can join and receive a Planetary Radio t-shirt. Members receive the internationally acclaimed Planetary Report magazine. That's planetary.org/radio. The Planetary Society, exploring new worlds.
Welcome back to Planetary Radio. I'm Matt Kaplan. Jack Gregg is Executive Director of the California Space Education and Workforce Institute, or SUSUI. If you think that's a loony acronym, you're right, because SUSUI runs the Lunar Regolith Challenge in partnership with NASA. You may remember that I reported from the first challenge about a year ago, when none of the 4 autonomous machines in competition came close to digging enough simulated lunar soil to win a prize. Even more teams came to Cal Poly San Luis Obispo this week to try their luck in the big sandbox. Sadly, the results were much the same as last time. Jack, I think we learned again a few days ago that it's not just rocket science that is really hard to do.
No, it's a whole variety of different technical expertise that's really important about space exploration generally, but specifically up on the moon. It's just, you'd think, gee, if you want to dig dirt, for example, you just take out your Tonka toy and you scratch away and you've got dirt. But it's not that simple.
Those were some complicated-looking Tonka toys that those teams brought this year. You know what? I thought this was going to be the year. I thought maybe one of the returning teams, knowing now how to deal with this nasty Regolith stuff, was going to come back and just hit it dead on, get the formula right, and walk away with $750,000.
Well, you're right. First of all, it did increase to $750,000. I think it was $500 for first place.
Yeah. You're right.
But it's a big incentive, and so you'd think that that's exactly what would happen. And frankly, coming into it, as I did, this is the first time that I was involved. I wasn't involved last year because I wasn't with SUSUI last year. But I thought, where we'd find contention was that we'd have a couple of people tied for first, and how are we going to figure out the tie?
Yeah.
But no, and just to let you know, one of the things that was so complicated about it was that people made it really complicated, so which is kind of a design issue. A lot of the engineering was adding this and adding that to the engineering process instead of getting down to some kind of simplistic, core, elegant approach. There were those approaches, but then they had all kinds of bells and whistles. I'm not saying that there were any regolith excavators that had CDs and
8-tracks,
heaters and radios and so forth. 8-tracks, right? But kind of, if you step back about 15 feet, you'd think that they did have all that stuff attached to it.
I had the same impression last year, and I'm going to date myself here, that there was a bit of a Rube Goldberg-esque quality to some of those machines. And I don't know, I'm not an engineer, I'm not trying to dig regolith, but some of them did look a little over the top.
Yeah, and I think that was part of the problem. And one of the requirements of the competition was that they do these the whole excavation autonomously. That is to say, you stick it in the sandbox and you plug it in because we provided power for them, and then that's it. You don't have a joystick. You don't do anything. It has to figure out where it is, who it is, why it is, what's going on, all by itself. And then it's got to figure out where to dump it, and then to go through that whole kind of drill. And I think that where we saw some real excavation was the second day after the competition was over.
There were demonstrations.
Exactly right. We had a number of them wanted to come back and demonstrate their technology, and in demonstrating that, where they did use a joystick and they didn't do it autonomously, we had some very interesting things going on. In fact, what was kind of neat was to also watch the expressions on the NASA folks as they were there taking notes and kind of watching the different technological approaches. Remember, it's a mixture between the application of technology and that dirt, because that regolith isn't like anything else. And so it has its own characteristics, its own density issues. It's very dense. It's very powdery. And they really wanted to see how that played out.
And I got experience with that because I was standing at the edge of the, if you will, sandbox last time. And it is not like... It's from someplace else. It's from another world.
It really is, yeah.
My strong impression last year was that a lot of those people were going to come back. They did. I bet many of them would love to have another shot a year from now. What does it look like? Do you think they're going to have a chance?
Well, as I'm looking at it, as I understand, last year there were 4 people in the sandbox, 4 competitors. This year we had 25 people sign up. After we went through the qualification round at the beginning of the competition, we had 16 who looked like they were going to qualify. We actually had 8 that met all the qualifications, and nobody was able to excavate the regolith to fulfill the prize requirements. But just kind of given that growth factor and the fact that there were people there from the press and from all over who really wanted to see this take place, my guess is that there's going to be more and more folks. So just playing a numbers game, as more folks enter into the competition, and as more people then have an opportunity to return 1 or in some cases 2 years, that we should be able to get to a winner, I'm hoping.
Yeah, I wouldn't be surprised. We're almost out of time.
Okay.
How does an event like this and supporting this fit into the mission of SASUI?
Well, SASUI's main mission is space education and workforce. And that's what the letters stand for. And so how this fits in is in a variety of different ways. First of all, it engages people who are themselves learning about science, technology, engineering, and math. You've heard of STEM, and STEM stands for science, technology, engineering, math, and that's a hot issue, not only in education circles, but very much so in industry circles, and NASA is very keyed into this as well. So if we don't develop the right STEM pipeline, that is to say the future workforce, we're not going to be able to fulfill this whole space exploration thing, as well as other technological areas. So one of the ways that the regolith competition feeds into that is it gives people an opportunity to learn about this sort of the very practical, hands-on, more than just a lab, but something as close as you can get to actually building something and doing something on the moon without having to get yourself shot up there to do it.
Jack, we're out of time. I hope to see you next year on the moon.
Cool. That would be great. Thanks, Matt.
Jack Gregg is the Executive Director of SASUI, the California Space Education and Workforce Institute, I think I got it right, affiliated with the California Space Authority, and we are at SUSUI headquarters right here in Pasadena, just maybe a mile down the street from